Okay, um, welcome to today's system design session. So today, as we discussed last time, in today's session, we are going to talk about the design of the telemetry. So I would like to look for a volunteer for today's design. Is there anyone who would like to design our telemetry? Anyone want to, do you guys know what is telemetry, by the way?
Yeah, you mean, so what I can think of telemetry is from the application perspective, right? Like we need to send the data on the response time, you know, just thinking from the, like not from any hardware related, like for example, there is satellites or trucks, right? Which are different telemetry, but specifically for the software applications, we need to know the CPU, the memory usage, CPU usage, total number of threads, and then some kind of application monitoring, APM tools, which basically takes those telemetry and prepare, right? So is that what you
Yeah,
mean?
that is a
Telemetry?
telemetry. Telemetry basically just a bunch of numbers and very quick, and
Correct. Yeah,
maybe
time series data.
maybe tens and 100,000 of numbers per second with sometimes there will be some keys and values, and usually the telemetry don't need any real-time read, because usually it will be read at the as a graph. Say that in a certain amount of time, we will draw a graph of the numbers, the values, a line chart or something, and also we will set alarm for those numbers. If some numbers go above the some threshold, we will get page. We will get some. There will be a phone call to maybe coming in the middle of the night and like have wake up to fix the problem. So yeah, let me write down some requirement here, and so here, so let's say that requirement would be like let's say 100,000 per second of record.
Can you share your screen?
Sure.
It's in the coder pad actually. I think
Yeah.
But it will not be visible in the video
I can
upload.
share.
Right?
Yeah, right. I can share.
Oh,
my
that's
screen.
right. Yeah.
So then we can have the record. So we can have 100,000 of record per second, and we can have no need to read current data immediately. There should be a graph.
What is the meaning of this point? No need to read current data immediately.
So if you send out telemetry data into the server, like we may not need to read the data right away. We can wait for 5 minutes, 10 minutes. That's okay.
Can we define immediately? So you are saying that like up till 5 minutes, it's fine. What's the time?
Yeah. And there's also another feature is alarm. If the number goes into some threshold, we'll get paged. Paging is out of scope. So yeah, this is the
This is the alerting, right?
Right.
So okay.
Yeah, this is the requirement for the topic. So yeah, the requirement is very simple, very straightforward, and I would like some volunteers try to try this out. So you guys
one more question I have is, so are we saying these logs and all, they are not considered as telemetry?
Logs?
Yep.
Logs can be considered as telemetry, but that depends. Usually the numbers really matter because we need alarm and we will use only the numbers matter. So
no,
yeah.
What will you do with the numbers if you don't have logs? Like if the number is high and if you don't have any other information beyond that?
Yeah, we can have the properties. Like we can have some number that value
is trace or something, right? Because if we
so basically you're saying like in the system it's just a matrix, not the logging data, right?
Yeah, so I think that the term that is used is metrics. Like these are metrics, right?
Yeah.
And logs is that other component which we are not building properly. We are just building for metrics.
Metrics, yes.
Yeah,
yes.
This is more like metrics. That's right.
Yeah. Okay.
And the logs, we can talk about these logs later in some different.
Yeah.
Okay, and just to clarify one more thing, like when we say within 5 minutes, so we are saying it's not real time, or like we are saying
not real time.
It's not real time. Okay.
So basically, the user don't need to read the data in real time, but in our backend system, there will be something handling the current data because we need an alarm. We need to have something to monitor those numbers. If say that current value that we have this can be the one matrix that category is CPU, and the value is 98. So obviously, we need to get that paged. 98% of the CPU usage. Something is wrong.
So, by the way, I would say, I mean, we are just building metrics, but logs are very important because if you get an alert that the CPU is high and it's 98, then you cannot do anything unless you know what is the environment, what is the machine, where is it happening, right? So all those logs are definitely important. Without
log can be in a different category of discussion.
Yeah.
So maybe the next time topic we can put the log because they are very similar. But let's put it way back.
But the problem can be different because log we need more storage, but with matrix it's just the aggregation of data.
Yeah, mostly we just need 5 minutes of the aggregation, that mean and max and average, or maybe sometimes we need the mean, max, and P90. 90% of time. There's a detailed definition of this. I can't find it, but there are definitely, we just need the aggregation result. We don't need the detailed result. So yeah, this is the system. Any more questions about what it looks like?
No, sounds good.
Okay, and so you guys have several guys. Do any of you want to try to design the system? I'm a little bit tired today. No, no one want to design this. Someone want to say something?
Jeet was saying something.
Yeah, I was just thinking, maybe I can definitely try.
Yeah, we can try to work out. Yeah, we can try to work out it together. And by the way, there is I just recently found there's the drawing mode. I just wondered how it's look. If you guys can try it out. I will give
can
the
you maximize it? No, I was saying if you can.
I just click on the
maximize it.
Yeah, I can give you the screen. And yeah, we can start. We can try out our drawing mode.
Okay. So you want me to share the screen, right? So that.
Yeah, you can share only your window. You don't need to all your desktop. Yeah.
Yeah.
This looks good.
Yep. Yeah, just 1 second.
I think if you will click on that button next to cross, it will maximize it, I think.
Oh, this one? Okay.
Yeah.
Oh, okay, it brought
Yeah.
a new window.
Okay. This is completely different than. Okay.
Yeah, this is something that we can use in the interview, real interview.
Yeah.
Probably the next one will be this.
Okay. So basically, the first, what I am thinking of is the first requirement is the whatever mentioned, the 100K per second record, right?
Yeah.
So basically, what I can consider is, let me see if I can get something. Oops, okay, yeah, let's see this one. Okay. Yeah, so this is what will happen, right? So we have the application. Okay, I don't know if I can write something within that. Okay, so yeah. So basically what I'm thinking, let me go back to the not using anything else. Okay, just the drawing one. Okay, so yeah, so on the telemetry, right? So so basically think about, we have the applications. Okay, so I'm just thinking this way. So this is the application one. Okay, and so think about, there are multiple applications, and this is what the telemetry server. Okay, so just to start with that, I don't know, this is actually okay. So this is the telemetry servers, and what we are thinking is, so I'll just that we need to push the data from the client to the servers, right? Okay,
We need to, yeah.
yeah. So so basically, like what I mean, one of the telemetry, what actually coming to my mind is that normally we use tools, Apm tools, right? Like the application performance monitoring tools, or any logging tools, right? Which are basically takes the telemetry data. Like if we think about New Relic or App Dynamics, or there is tons of tools are there, right? So one thing is that we mentioned that we will get 100K record, 100K per second records, right? So one thing is, are we going to focus on how the application is sending, or we just need to focus primarily on the server end, right?
Yeah, applications and sending from application maybe just a simple API
Yeah.
to submit the
Okay.
JSON thing.
Okay.
And
Okay.
yeah.
Yeah. So in that case, right? Let's so basically from the telemetry, like from the server side, what I'm thinking is that we need to have some of the APIs which will be receiving the telemetry data, and think about, there will be some agents are running. There could be different applications, let's say that from Java, or from like Ruby, or like Node, or any application .NET. And then basically what actually that does, think of, like specifically most of these products are SaaS products, right? So they need to provide the APIs, and then these agents need to send the API, like basically we just need to, from the client, need to push the data to the servers. Okay. So one thing as part of like on the requirement what you have mentioned, correct me if I'm wrong, because I do not have any experience on this one, so I'll just go with my idea, but please feel free to chime in anywhere you think can be fit in. So the first thing is that the API comes into the picture, right? So as far as I don't know, it is I cannot. So whatever the API comes into the picture, that one thing is that like we need to get some, like think about the collect metrics data, right? So basically there will be API which will be, like something collect metrics, right? Let me go back actually and put it in the text. Okay.
And if you have a big chunk of that text, you can use the coder pack itself.
Oh, okay. Okay. So here, right, I'm just putting the text, like basically something like, collect matrices, right? So on the collect matrices, we need to collect the data, but and again, like what actually this is going to be. So this is initially just defining the APIs, right? So basically defining the APIs, what the initial APIs will be look like. So one thing on this, that we want our clients to send the metrics. Okay. So basically this is, going to be a post call, and what are the data. So right now what I'm thinking, let's think about because it could be different kind of data, right? So if we think about a schema, so basically this is something, like will be there on the category, and basically the agent is there on the client side, and it is part of the application. So this is something on the category, right? So what will be the category, and constantly actually it will send out the data. And one of the thing which is important is that how frequently the telemetry data need to be collected, because normally if we are making so many requests to the because these are basically internet, right? These are the SaaS products. So we just need to make sure that, we are not overwhelming the core application, rather than, like we just need to make sure that let's assume here that, like I'm just putting it that every 1 minute we just need to make a call. Okay. So whenever the app agent, right, so the agent will make the API calls, and it basically, like the agent will have some of the libraries. Let's say that, based on what client, basically like these are the agents, right? Like whatever the client needed. Okay. But essentially we are actually providing the APIs. Okay. So in this case, so the category could be something CPU, something, memory. Okay. uh, or it could be anything, and it depends. So first thing is the category, right? So once we get the category, and then we need some data, right? So here actually another thing is coming into the picture, that what actually data we need. So I'm just assuming that in a simpler system, right? So let's say that this is something like a like some, like a um, like what actually the value is there, right? So let's say that from memory it is going to be like bytes, and the type. Okay. So basically this is going to be another type which is going to be defined, whether this is a based on the CPU, we need to design what actually the collect metrics will be doing. Okay. And so the type is depends if it is going to be a like for example, in case of memory, it is going to be defined in the number of bytes, or it is going to be numeric if it is going to be CPU usage. Okay. So considering our initial basically no need to starting with the CPU one. Okay. With a very simple telemetry thing. I don't know, this one should be moving. Okay. So let's assume that we collect from the API. Okay. And this is what the important API is, that we just collect it. And now the question is coming that we need to in a simpler systems, we need to store this thing, right? I'm just trying to think about whenever we have to connect to a persistent storage, right? And one of the thing is that before even the storage comes into the picture, what I know that let's think about, this is the storage part. Okay. So this is the storage. We will discuss about, like whether SQL, no SQL, all these things. But what will happen primarily is, so this is basically the API, right? Like whatever the API we have written here. So the API will be there. And then, so basically think about, we do not wanted to have anything synchronous. Like most of the telemetry systems are, asynchronous in the nature. So what will happen? I'm just assuming this server whenever I mean, right? Like let's start with a very simple one server, and then what will happen, we need to maintain the queue. Okay, so now what will happen, like these are the queues. Okay, and we can think about what technologies and other things as we progress, but the architecture is that, so this is the queue. Okay, let's assume that we will use everything for the queue, and of course we need to partition the queues, right, based on what we need to partition. One of the thing we'll discuss about that, right? Definitely here it is coming into the picture that, remember, on a telemetry system there will be so many matrices will come, right? But we just need to make sure that how, like, not that everything will be um, yeah. So okay, so what will happen, like on the server it is going to be on the, whenever we collect a matrix, and feel free to chime in. Okay, looks like Iran or Abhishek or others. Okay, so here, right, my thought process is that I'm going to put it in the queue. Okay, and there will be some
yeah, I just want to say one thing.
Yeah,
I
sure.
mean, that's good, but like, can we simplify? Like, can we just do one simple, easiest thing first, end to end, and then we can, I mean, see the problem. So, I was thinking. So, let's say we have just one.
Okay. You mean the one telemetry server, right? One node means, correct?
Yeah, we can abstract that there's
telemetry server.
We can assume that you can
Yeah,
simplify
so
as a
telemetry.
cluster. Go ahead.
Yeah. So telemetry server is the server that is processing, but I'm saying, so your application will be running on some machine, right?
Mm-hmm.
And that machine is,
Yeah, unable to hear you. Oh.
Am I audible now?
Yeah, you're audible.
Okay, so I was, let's say we have one machine. Okay,
Mm-hmm.
on that one machine, my application is running.
Mm-hmm.
So now my first thing I want to understand is, so that log, whatever that log is, that application will be, either that application will be generating the log. By log here I mean that metric, right? So
correct.
That application will be outputting that metric, right? So let's say if I make a call to my service, and if it returns success, then it can log this metric that I successfully returned success for this API call. So now this is one metric, right? There could be other metrics like CPU and all, but let's take one simple example, that I have my application running on a machine and I'm logging that metric, that whether the API call was success or failure, right? So correct. Let's build a very simple system that, so my API, so this is the metric, success or fail, right? And now, so now like there are a lot of questions in my mind. Once we solve that, then we can scale and all those things. So one thing I was thinking, now will that log that this response was success or not, will it be first written to locally on that machine, and then some telemetry server will read those local logs and upload, or is it my responsibility? Is it the responsibility of application that every time it gets a call, it also needs to make another asynchronous API call to this telemetry service to log the data? Okay. So all those things. So yeah, so let's first see from the customer point of view, that what a customer customer has to do, like me as a API developer, what I have to do and what I will get, and then I think it will be easier.
Right. Yeah, got it. So yeah, so that's a good point, right? So think about, for example, now I'm coming to the client side, right? So what basically you are saying that, hey, I have the APIs, correct? And whatever the API is there on the application, correct? So what happened? Let's say that some client is here. My drawing, unable to. So bear with me. This really bad one. So the client actually, that's a good point what you bring up, right? So now what happened? Client hit, right? So from the application, it returned a 500 error, correct?
Yeah.
So basically, something bad happened on the application, okay? Or it could be a 400. Basically, we care about most of the telemetry. They record not every data. They actually, otherwise it will be huge overburden. But they do a sampling of the data. Actually, what actually comes, from the server, right? So let's assume that on this particular API, we got a 500 response, and then we have to, whenever whenever we are going to have so the client, whatever the server is running, right, whatever the language or something, like it has to connect with the server and send the data. Okay, so the question is coming that I know that it comes with the agent, but to be honest, right, I do not have the visibility, but I think definitely we can brainstorm here. So what would happen, that one of the question you raised, right, in this case, and these are the important metrics on the application, and specifically this metrics is the HTTP metrics, right? We wanted to, let's say that our application is continuously throwing 500, and we wanted to make sure that it is alerting to the right people. So so one thing, what I can think of is that there used to be like every application. Yeah, I'm a little bit thinking here, but if you guys have Abhishek and others, right, if you guys have any ideas, let me know. What I can think of is on the application, whenever we are having let's think about in Java, I'm not sure, right? We have there has to be agents, and the agents has to be collected the matrix. Okay, but how it is going to be collected, that is one of the critical part of the. Now we are coming to the client side, right? Like server side, we know we can push it, and then but I believe, yeah, so this is one of the thing is that what will happen on a simpler system is so on the client side, think about there is on the client application, let's skip about like the agent and other thing. Okay, so on the client application, we are going to inject some of the properties that where actually the telemetry server is there. Okay, and then then we can ingest the data to the API of the telemetry server. Okay, so
you are proposing that as an application developer, when I'm writing the code in the setup, I will mention the connection to the telemetry server, and whenever I have to log a metric, I will make that API call and then log that metric.
So basically what will happen, right, on the application, it will be providing a SDK. Okay, so what will happen on the application, like it is going to have a API, basically think about not sure about other languages, but think about there is a SDK. Okay, and we are going to make call to the we are going to this is actually another approach which is which telemetry provides, that we can send the granular data to the directly to the API. Okay, but I think if you have some other suggestion, definitely we can explore, but this is what actually my thought process is, right? On the application, whenever like we are going to have so basically think about any application, normally there used to have a pre-processing and there used to be post-processing, right? So this is my application code, right? And it went to the external world, then it come back, right? And whatever it happened, so there is to be a, like this is basically like the request and response cycle, right? So we send a request and the code got executed, and on the back, right, we are actually returning back to the client. So what will happen, like it is, if we are going to collect, let's say that these metrics, like in this case, it is going to be the HTTP metrics, okay? And HTTP metrics, we are basically care about whether it is a 200 or it is, I don't know if I can, scroll it actually.
Okay. Can we also add?
What is?
You could just keep it 100% and try to find a different place to draw. This canvas is very big.
Yeah. Okay. Yeah. So so on the application, right? So it is, so basically we are going to make the call, okay? And
so
then
let's decide on this thing. What do people think that?
Yeah, sure.
Yeah, I think we can just use whatever way, use SDK or using the HTTP request directly. Just send out the HTTP, just send out the request, say that we have this value, we have that category, and that's it for the API.
We are sending HTTP request, or are we first logging locally and then some agent is getting the data from the local machine? I have seen like
correct.
Yeah, I don't think there's such a need. If it's a telemetry server, it should handle the data very, very fast.
Yeah, and let me tell you one of the thing what happened, right? If we think about the telemetry server, they actually they verify your identity, and it actually comes over the internet, right? So whenever you have to provide, and of course, whenever we make a call, there is a big part of authentication, and you need to make sure that you have the right API key. So yeah, I mean, bottom line is that there is an agent, right? Because which actually sends the data to the server API via internet, okay? And these are the HTTP calls actually what it is sending, correct? So in this case, what I'm thinking that we can start with like think about there is an agent here, okay, which is basically like collect the metrics on the, of course we are going to have the, and remember it actually cannot really collect from the log, okay, because the logs are like if we think about log patterns, it varies. Like for example, if you go to web server, there is a standardized logging pattern on the product, because normally we do not write on the Nginx or any kind of server, but whenever it comes to the application logs can be varied, okay? And that's actually a different category, that because the telemetry works in a very simpler way, that it has some APIs, and we can see actually like what I have seen from the products, that they will give the API and the agent will be taking the metrics, okay? And now the question is coming, that part is kind of abstract, that so the metrics will be depend on how the application flushes out the metrics, okay? Like if we think about a Java application, it has the JMX plugin, okay, I mean, which actually comes on the application, that it flushes out the metrics, and then it has the custom collector, okay? So the collectors will be part of the SDK, which actually takes the metrics from the JVM. Because remember, same thing, something will be there at the .NET also, because these SDK, like think about if we are building SDK and we are writing some of the APIs, then we need to write on top of the language APIs, okay? And language API.
This falls into design the SDK domain,
exactly,
so it's kind of out of the scope of the system design.
Yeah,
let's assume that client can send out the metric whenever it wants.
So see, my question is, if for my every call to my service, and probably at multiple points, if I am making those API calls, then my service should have almost the scale of my service, like how many requests my service is getting, whatever is the scale, my telemetry server should also have that scale, because it will be getting proportional requests to log those metrics. But if we combine the data, because we are okay with 5 minutes, so if we combine that data and then we send those requests to the telemetry server, then we can then we will not have so many calls, and then we can handle things easily. That's why I was a little worried that if for every request, and in my request when my code gets executed, I might be I might be making API metric call multiple times, 3-4 times, right? And so
correct. And let me tell you
3-4
one
API
of the
calls.
thing actually what normally happens, right? So again, we have two parts, right? On the client side, so the calls actually happens whenever you get a 200 request. Okay, doesn't matter, like 201 to 200 anything.
But it's not 200. We can log it. Like metrics can be anything apart from the service. Like
correct. Yeah. So what I'm trying to say, right? So these are the requests. Actually, we don't have to send 100%. Okay. Because remember what actually matters, the most significant of the telemetry is to alert when there is error, and the products are actually tuned on that way. So let's say that you run 1 hour with 100K request. Okay. It is not going to send 100K to the telemetry server, right? Otherwise the server is definitely, because remember these are actually cost on their end. Okay. And also there is a lot of networking. So what actually they do normally, they actually and that's what you won't get 100% reflection what is happening on the application on a telemetry pager. Okay. And that I have seen personally. Whenever I go to one particular application log, I will see 50 exceptions, but in the telemetry I will see only 5. And
how
this
happen?
Yeah. So how did happen is, so basically at that time, right? So whenever there is so this is actually part of the telemetry configuration, that we do not send every request to the telemetry server. Okay. Let's say that our transactions per second is 1000 or maybe 2000 or 3000. Okay. So this actually control on the client side that how, and again, like I'm not sure, but there is algorithm that it actually calculates that how much percentage of the data it has to send to the telemetry server, so that it can completely measure the health of the application. Okay. So think about it, right? See that 5 minutes, what actually came, correct me, Hiran, if I'm wrong. So the 5 minutes is basically, so the data will continuously flush out to the server. Okay. It is nothing on the client side. Client really don't know anything. But let's say that you send a alert. Let's say that there is a application error happened. We are unable to connect to Maps API from Google, right? And we are on the Uber kind of application at 12, right? So by this time you get a pager, it is going to be 12:05. Okay. So this is the delay. My understanding is that not that 5 minutes we are going to pause and send the data. Correct, Kiran? Like that is the assumption, right? So the delay is on the telemetry, when to process and when to notify the data. Correct?
I was thinking
Yeah,
why
no need to notify the client. You just put the data in the server and that's it. And server will go into the pipeline and process data. And that need 5 minutes of the process.
Yeah, correct. Yeah, because this has to, and again, I have seen this also in the production. The alert will be one time, and remember, this is not a breaker, because like whenever there is a bunch of error, 1 or 2 minute lag, it actually happens, and also we can see in the charts. Okay, because when the telemetry like data comes into the graphical way, we can verify that, oh, this alert starts at X minute, but application actually and started before that. That is fine. Okay, there will be a lag, and that is expected because there is so much of data coming. I think Neha was saying something. Sorry, Neha.
I have one question. Why did we consider push model here, not pull? Like, why can't servers, like, they will pull that data from the agents running on all the application machines?
Yeah, that's a so like
pulling the data from agent, that is kind of out of the scope of the data design. And I would not recommend to dig into it too much. So let's assume that we already have the input of 100,000 per second of the request sent to the server's cluster.
Yeah. Yeah, I think now, like I believe we are on the client side, right? Like how to send the data. So are we good to move
Let's say that we already sent out the data to the client.
To the server, right? To the telemetry server, right?
Mm-hmm.
Okay, yeah. So let me erase some of the stuff here. Okay, so basically, let's assume that we send it to the server. Okay, and there is various ways
you can use you can move the canvas so you can get more space.
You mean this way?
Yeah, you can move and we can have more space.
Okay. Yeah. So so this is what actually now we have the collect metrics API, and there will be of course it is going to have the HTTP and other categories. Okay, so now think about what will happen at the server end. Okay, can I move something, this one, like this piece? I don't know. Okay,
I think there's a selection.
Okay, so that is fine. Anyway, I'm going to yeah, this is something so let me clean this ones. Okay, so okay, so what will happen, we have the so right now the server is there. Okay, so let's assume that we have the queues. Okay, so I'm just considering like on a single queue right now. Okay, and then we are going to have the worker nodes. Okay, so these are the worker nodes. Okay, so let's assume this is w1, w2, and w3. Okay, all the worker nodes are there. Okay, so these worker nodes are, of course, like when we scale, we need to design the like basically they are going to have the right partitions, what kind of matrix is coming to which particular queue. So let's assume that all the workers, they are continuously polling the data. Okay, and basically let's these workers can be so basically their job is just to whenever somebody a message comes in from the API, his job is that get the message. Okay, but whenever we get the message, so the API is, sorry, the worker will have some of the transformational logic, right? So let's say that if it is going to be a CPU data, then we know that, like how to, so yeah. So basically every type of metrics, so we can divide the workers to their category, what actually they are dedicated for, because there is a, right now we are just focusing on the CPU, right? Or maybe memory, like in a real system design interview may not have time. And then this is going to flush to the DB. Okay, so in a simple scale, so my assumption is that, so this is going to be the DB. Okay, so what I am thinking, so this is basically going to flush to the DB, and of course the DB, we are going to have the like definitely there will be partitions, and there will be, so the DB is going to be sharded. Okay, so now one thing what I'm thinking is let's say that like on the database side, one of the thing which normally scalable, and in this case, right, SQL is okay, but preference would be something like NoSQL, right? So why NoSQL? Okay, or maybe why SQL? So what my thought process is that whatever the metrics data comes in, they are really not related to any transactions, right? And what we want is that they have to be infinite scalable. Okay, and one of the thing is that and there is no acid property, and these telemetry datas are by nature itself they are asynchronous. Okay, like so the data comes, and it is not like that instantly you will get a, if you get a error at 12 midnight, you might get a 12:05, or you might get a 12:02 or 12:03, something like that, right? So so this is going to be the database. Okay, so So this is, and whenever the database, like we just need to push the data to the database. Okay. So in the database, the next question can come into that how we are going to, persist the database, right? Like what kind of, what kind of data structure it is going to be, whether it is going to be Cassandra or it is going to be document related DB, right? So that is the, I do not think so, we have categorized that specifically on the DB design part. So what I'm thinking, let's assume that it goes to a, like distributed and sharded, to the database, right, across the partitions, and it has to be very, very quick, right? So the next thing, so that is one of the things which is mentioned is that 100K request per second, right? So the 100K request, and remember, like this is something we just started with a single server, and whenever the messages like here, this can be easily scalable to take, like basically think about, and of course there would be load balancer and web servers and other things, but the question is that, and this also can be scalable, okay, because this queue we can pretty much define based on the category type, okay, and these workers are also scalable based on the category type, okay. So what I'm thinking, very simple architecture, this also can be scalable and they have to push the data, okay. So so any question or any thoughts? I'm just,
Yeah, I have some comment on the front end. I just thought about that. So
sure.
because this is the telemetry, this is metrics data, and if we miss one or two data, and it doesn't really matter. So I was thinking that first of all, the HTTP request need to be very fast, and it can be lost. So I was thinking that we can consider using some binary formatted requests like Google's BUF protocol or Facebook's Thrift, and the request itself can be UDP because we send a zip.
I see.
That's it. I don't need to care about the later work.
Yeah. Okay. I see. Yeah, that is true. So basically, then in that case, right? Normally, whenever we define the APIs, then behind. So basically, you were saying, yeah. So binary format is actually one of the good thing, right? Because these datas are really, not really. It's basically system generated data, right? The output of the thing comes into whatever the telemetry EY part is going to be, right? Like how basically read the data. Okay. So basically, you were saying the on the API side, it can be UDP, right?
Yeah, I also that. And on the back end, on the database side, so one of the features of this system is that we have the queue, we have some workers to process data in batch and write them to the database, and then it is immutable. So yeah, I'm thinking of transitional database. I'm not sure if the transitional database or NoSQL database is a good choice because basically we will write a big chunk of data with all the numbers. So we can write a big chunk of file, and also like this is a typical streaming and micro batch style. One of the best practice is that the process in the middle that should be revertible, because when we are deploying those what we call that, so yeah, the micro batch process may fail, and we need to go back to the previous checkpoint to reprocess the data.
Oh, okay.
Yeah, so that basically it will generate a bunch of big, huge files, and later I don't know how to consolidate into some form that we can query in the front end. Yeah,
okay, so you were saying like this is something like the micro batch processing way, like it will be just sending the data in a smaller batches, or can you please a little bit?
Yeah, it will process maybe 5 minutes or 10 minutes of the data in the batch and categorize that. So we may get the data for the CPU, we get the data for the memory, and we will slip it out and do other things like doing the alarming.
Okay.
Alarming, they can leave it later.
I see. Yeah. Okay. Yeah. I mean, I need to explore a little bit on that part actually. So one thought process, like I haven't. There are some of the time series DBs are there, right? Which is exclusively meant for the time series data, because like in this metrics, it always a time series data, right? And it always go in one direction. So it's not like that, like whatever the data, but yeah, I haven't have any experience on the time series DB. But what I know that most of the telemetry, specifically on the like they used time series DBs to store, but how it really internally stores to the disk, and what actually the architecture, that could be one of the thing. I believe it would be better that, because remember, whenever we really don't care about the human readable format of these APIs, right? I mean, whenever we persist the data, as long as somebody is going to remember, once we feed the data, like there should be some way to like so this is actually one part, right? And the second part is that how to in what I can think of is on the front, I mean on the application side, right? On the front end, like it has to connect like the component, because this entire thing actually in one pipeline, okay, like where the data ingestion happens. But the second thing can happen is the data retrieval, right? So let's say that there is a UI, and those components, and these two things are completely separated, right? Because this part need to be really highly scalable, like how the data is coming to the server and how the data is going to be fetched. And so there will be other components on the like on the user interface side, what I can think of. But yeah, so I think you guys, yeah, we say.
So few questions. So one thing that Hiran has mentioned is using the using Protobuf or Thrift encoding formats, right?
Right. Yeah.
But those needs schema, right? There should be schema. So it should need schema to encode the data, and on the telemetry server also we should have that schema defined so that it can understand that information. So how will that happen?
I believe Thrift have the schema. They can handle the schema version change. They have, I remember that Thrift have the number
I'm not talking about the version change. I'm just saying that a simple schema. So basically what happens is, at the source side, the schema, that this is the schema, with this schema I'm going to send the data. Receivers also know that this is the schema, with this schema I'm going to receive the data. So now, using that information, you can make the data smaller and you can just send the data because receiver knows the schema. But here, so basically, if you are sending a lot of data with same schema on internal services, then these protocol buffers and all are good. Here, I see that we're going to send the same data, but because it's an external service, how will we do that schema contracts and all? Because beforehand, first you have to do schema contract between the source and destination, and then you send the data according to that schema.
Yeah.
I don't understand what's your concern here. We can have the schema defined on the client side and server side. If we all agree this schema, we should be good.
Yeah, but I think what Abhishek point, right? So if we have some of the APIs, I know that GraphQL now most of the APM products, right? They are coming with the GraphQL apart from the REST APIs, right? Which is by default, right? So correct me if I'm wrong. Like if we are going to define some thrift or protobuf, right? And let's say that application wanted to send some custom data. Basically here, right? The communication is not between within our services, right? So basically this is the boundary we are crossing the chasm kind of, right? So this is one area and this is another area, right? So in that case, two, because internally Facebook and Google, right? Like you can use thrift within it, but whenever you are defining something to the external audience, I'm not sure how the community and the folks can understand the protocols, right? Because GraphQL is okay,
exactly.
right?
Yeah, actually, there is I can't remember which service, maybe the Cassandra or something that they define the REST API. They also define their own API using the Avro or something.
Oh, okay.
Yeah,
okay.
something similar to Thrift and Protobuf.
Yeah. Okay. Yeah, I mean, that is also a binary protocol, right? That is true. But that actually, yeah, I mean, I think Abhishek, you did one session, right, on the protobuf. But yeah, I mean, still, if we are thinking of, Kafka or like specifically, they are much into the, what I can think of, on the domain of server to server, right? Because think about it, right? Like if you really wanted to, yeah, I mean, I think that's a really good idea that like how we are going to send the messages with very minimum bandwidth, right? But yeah, maybe another day we need to.
Yeah, usually the service we don't need very strict on the bandwidth until something like database. We need to insert a big chunk of data.
Yeah,
or something like telemetry, we need to send it fast.
Correct. Yeah, got it. Yeah, makes sense. Yep. Yeah, that's true. Hello?
So can we dig more?
So did you understand the problem here on with Protobuf? So the problem with Protobuf will be that so the data will be encoded, right? And it will be in the form of bytes. So how will the server understand that what kind of data it is? And so now, like, I mean, like how many schema files are we going to put on the server, and then how will it know that what request was for what schema?
So Abhishek, one.
So and with JSON, if you're sending the data in the form of JSON, this simple thing is, if the data is in the form of JSON to the user, when he wants to create graphs and all, you can just display the JSON data as it is, and then he can create the graph. Whereas if your data is encoded, first you have to know that how to decode that data. And for that, you need those models, those protobuf schemas and all that you have defined, which I don't know like how you will do.
Yeah, basically protobuf, you can think about the JSON in the binary format.
No. It's not, but you need the schema also, right?
Yeah.
So with JSON, you don't need schema. You don't need schema. On the receiver side, you don't need schema.
On the client side, you mean, right?
Yeah, that's why what he was saying is that external services, if external services communicate, they use JSON because they don't need to.
Correct. Yeah.
They don't need to know the schema. But here,
of course, the internal system will need the schema. You need to know that what kind of data. You have the field of data about the value. You have the field of category. Tells us what kind of category you want to put the data. So this is schema, even though the JSON. Just send out the port and value, and you're not using the category or using cat, then the telemetry server will not understand this. There's always a schema required in the client side.
Yep. Yeah.
I think always need a schema.
Yeah, we already need the schema, unfortunately. And the protobuf Protobuf can be something like you define the first field can be something like the name, and then we can have the list of the different values. So then basically it's a JSON with a schema in a binary format. You can think about this.
Yeah, and also, you know, like lot of these products, they are using the GraphQL, right? So the GraphQL, the good part is that you know, like basically the data, right? Think about a normal REST. There is a lot of, you know, repetitions. You really don't have to send it, right? Like, and that is one of the thing what I'm seeing. You know, like just to share, right? So if you see, this is something what Neuralink are having there. You can query with the node graph, and that is one of the thing we discussed, right? Like you know, like so basically the APIs are explored with the with the GraphQL API, so you can pass the query whatever the. I mean, there are actually the the REST APIs are of course there, but this is something, you know, like something new. Just to give some examples, right, in the real world, how people are thinking from one of the, you know, leading products that you know, like how basically, and if you see the operations, it's exactly, you know, like you can, and remember, this is little bit different, okay? Whenever we are talking a telemetry, this actually, I mean, there are two parts here, right? Pushing the data to the telemetry server, querying the data from the telemetry server, okay? So what we are talking about is different, and this is actually one step ahead, that, you know, like whatever we discussed, that, hey, we push the data to the database. Now there is a UI, okay? But remember, UI is one part, and in the advanced, you know, like a production systems, we really cannot always determine on the UI, and we have to write our own queries, okay, to get the different entities. So that's what, like most of the product do in similar or a different way, you know, from one another. But the question is coming into that, hey, you know, now we store some entities, and what actually the entities mean. Transactions is one entity, okay? Think about that way, right? Or your metrics is another entity, and which are pretty broad, okay? So they actually so whenever we push any memory data or CPU data, right, so they store to these ones, and then you go ahead and make a call to the query, and you say that, if you see, I mean, this is the actual GraphQL that you query, that, okay, I want you know, like whatever the query, that whatever the counts, and you give your entity name, type, or whatever the GUID, and then it will just return the result. And this is actually their advanced one, like the GraphQL. I yet need to explore some of the thing, but the concept is same, you know. I mean, which is definitely um, uh, beyond our this one, right? This design, right? Okay. So normally till what time this session continue here?
We usually end at 6:30.
Oh, 6:30. Okay.
Yeah, and actually, I think we need to discuss a little bit more on the middle side, the process side, and the queuing side. Yeah, and that will be very straightforward. We can use the existing the logging service like Kafka's service to manage that queue. Even
Correct.
there's just some term of logging and the queue, and in the middle we can have using some what's it called, that macro batch system like Hadoop or Spark kind of thing, like process a big chunk of data.
Okay. But it, you know, like yeah,
Spark,
yeah.
SPARK.
So one thing is, so the data, so Spark is kind of the analytical side, right? So those are actually, you are right, because another thing what I have seen is these telemetry tools are actually very smart. So they gave you some of the data on the machine learning models actually. So what I showed you, right, in one product. So they have multifaceted data. Okay. So one thing what I have seen is they will give you in last 30 days how is your response time looks, and I believe this is what is important, right? Like the batches has to run, and basically remember it's not about what we are getting right now, also getting, you know, like over the period of time how the scalability is behaving, right? Let's say that we ramp up from 1 million user to 1 billion user, but that does not mean that, you know, like if the response time is continuously growing, we may not observe on the alerting, but at least what I have seen that you know, like the systems actually give those data, and I believe this is something can be useful on the processing. And also they have like predictive alerting, which is runs based on the machine learning. But again, that's a complete you know, different thing. Let's say that if you are getting alerts, let's say that you have a, you know, like continuously you are getting from a system, it basically says you, but how, what algorithms, you know, that's a complete different thing, right? Okay. So so one of other thing is alarm if the goes into some threshold, right? Yeah. So how you guys think this alarm part, right? So like how to, let's say that we got some data, we store it, right? But normally how does that component works? Because that is a you know, let me you know, delete it. So let's brainstorm a little bit on that alerting part. um, okay.
My understanding of the alerting part,
Yeah.
from the Spark recommendation is that Spark will reduce the data into for different keys, and the key can be the category. So this key can be the CPU, and that key can be memory. So it will, if the CPU, it will check our setting to say that what's the alarm of the CPU. So the alarm can be something like in the past 10 minutes, we have 80% of the data, 80% of the value is about 90%. So in this way, the reducer will have some context to say that if the current key is a CPU, and we will do this operation like check the previous data, and if you have the sliding window to check the how much percent of the value is above 98%, something like this.
Okay. Okay. So one thing, you know, like how does the alerting system uh, knows that, you know, like so basically is there any scheduler, or is there any daemon thread, or how does actually so somehow the data is coming to the database, right? And the alerting system, normally what we do that, you know, like the application owners or the, you know, the team, they basically go and config, right? Hey, this is my alert name, and these are the metrics. So I believe there should be some database to store the alert configuration, correct?
Yeah, there should be
Yeah.
alert configuration, maybe in the DB, maybe in the file, in anywhere.
Yeah.
So
Yeah.
writing the alerting
Yeah.
system can be some maybe simpler expression, and probably we can turn that impression into some function and pass it into the system. Like if
Oh,
the
okay.
key can be CPU, and we pick up the function to say that you process this piece of code. Remember that I'm not sure if you know about the Spark, but in Spark that we can, yeah, this is about function that in Java we can compare a function, and we can put this function everywhere into different nodes. So using that function to
So you
process
mean the
data.
serverless like Lambda function or?
Yeah, something like Lambda, but even
Oh,
smaller,
okay.
even lightweight.
Okay. Okay. Oh, okay. I see. So basically, it's basically you call that function and the function will trigger something. Is that the function you mean?
The function will filter out the data and put the necessary
Okay.
context value into some context. So you can see that currently I see, so let's say it this way. We already have we already have 10 values, and currently none of them is about 98. So when we accept a new value, we remove the old value, add the new value, and see if 80%
Okay.
is above.
Oh, I see. I see. So, okay. So basically that has to be Okay. So basically it's a sliding window, what you mentioned, right? So let's say that we got the data, right? Like, and one thing I'm just trying to understand that, so whenever we get it, right, and there will be some kind of threshold, right? So here the threshold will be defined in the configuration DB, and the alerting, the system actually call that, hey, I'm just giving something CPU 90. Okay. Oops. These are actually, let me put it to the text. Okay. So let's say that CPU came as 90. Okay. And the second instance, so this is the first instance, and the second instance CPU also came as 90, right? And the third call we are making CPU as maybe 92%, right? So in that case, like all the data goes to the alerting system, and the alerting system, the alerting processor, right? So the alerting processor knows what actually, so I mean, of course, the alerting system has a configuration. Maybe the alerting, like somewhere it has to get, I don't know if can connect to the DB, then in that case, we don't need a, just to simplify, right? We may not need this one. So let's assume that this alerting processor knows about what the alert system is, right? So in our case, we define CPU as let's say that 90%. Okay, 90%, and the duration is very important, right? So 5 minutes. Okay.
Yeah, the data ingested can be not very reliable. There
Correct.
could be
Yeah.
some spike.
Yeah. Correct. Yeah. So in this case, like we are saying, trigger an alert whenever you see a CPU percentage of 90% within 5 minutes, correct?
Let's say that 5 minutes.
Yeah, so let's think about this way, right? So we are getting the data, let's assume every 1 minute. Okay, every 1 minute, and this is a running window. Okay, so every minute we got the data. Okay.
Yeah, and some minutes may not have the data, and some minutes can have the duplicate data.
Correct. Yeah. So this is kind of a infinitely time series, right? So in the first time we got 90. Okay. Second instance we got 90. Assuming we are getting third instance we got 90. But remember, our threshold is 5 minutes. Okay. We got 3 instance 90, which is fine. And then what happened? We actually moved to here, right? Let's say that, yeah. So another, this is, I believe, the system is that we have 5 minutes, okay, and we are getting at first minute, okay, and in the second minute also we got a 90%. So basically, still our window is 5 minutes, right? Then on the third also, because remember this is what 5 minutes. And this is what it will come 6, 7, 8, and it will continue. Okay, so the next window start only from here.
4.
Then it will come here to here. Okay.
Yeah, that's a window, but you make it one slot bigger. You see, it to be from 0 to 4, not 5.
Yeah. So we got 90, 90, 90. Now if we are getting, let's assume these two slots, we do not have anything, right? Now the count is basically count is 3. Okay, and this is the standard sliding window, and I think, yeah, this is the right practical application how it gets measured, right? And then we go to next minute, right? We got let's say that 90. Okay, so in this case, normally 5 minutes window we do not set, production like systems, we just measure a little bit because sometimes there used to be some spike. So, but yeah, considering that, now the count is 3 at 5th minute. Okay, so what happened? We got another one, but remember we just moved actually. Okay, so we actually come here. So now the count got reduced to 2. Okay, but and again we got another 90, same thing. So now we are from second, so this slot, right, which is actually 3, it got increased 3. So this is okay, it won't actually trigger the alert, but I'm just considering another 90 and another 90. Okay, so basically at this window, so now we are at this 5 minutes window. Okay, we are at 4. Let's assume there is like continuously we are getting, right, and this is, there is some CPU usage happens because of some external processor is taking time, or we have some bad code we push to production which has memory leaks and other things. Okay, so now the question is coming that, hey, we have a problem. Okay, so this count is now 5. Okay, and now this is matching with our whatever the alert we set. So some action need to be taken, right? So normally there has to be, so the alert processor has to integrate with PagerDuty, right? Which is kind of, very well known on the alerting world. And also it should be, I mean, there could be multiple things. It's not like that. And this is again another configurable part. So another thing is that there used to be email. We used to get the email also, right? So that we need to know as part of this one. And then these are the API integrations with external third parties, and there will be Slack and a lot of things, right? So then we push the message, and then it flushes out to the notifier and it comes back, right? So that is the one way to to measure, at least putting the data. So the only thing what will happen is all the processing, right? We really do not care about, let's assume that, right, if this server dies, okay, like in the worst case, then what will happen is we might have a like if there is a issue, I'm not really sure how, but potentially these things can be, it doesn't have to be, it can be in memory, should be fine, correct?
Yeah, usually if there is the data is not available, there will be another alarm trigger say that
Correct,
in the
yeah.
5 minutes, 50% of data is missing. Then there's a problem.
Right, yeah. So yeah, I think this is the because this has to be very fast, so that's the reason, which is the in-memory one, because we just wanted to make sure that and this is the one of the critical system, and yeah, I still need to learn about how the actual products, but I believe this is kind of sounds reasonable to be a actual application, how they're going to detect. Okay.
Yeah, I think we have only 4 people here, and I think everybody's tired.
Yeah.
So yeah, we can just stop here. Maybe next time we can have 1 hour and 15 minutes for the buffer. But yeah, I think the system is pretty complete. Do anyone else have a question for this? Because I'm thinking that should we talk more about this on the next time, or do we want to switch to logging?
Yeah, actually I joined normally in the weekdays, right? It's a bit difficult to join at the time, but how you discuss, right? In the next week is the plan to. It's better to be prepared and know at least to get some ideas, right? That will help us to
Yeah,
brainstorm.
previously we usually at the very end when everybody is tired, we can talk about what we are going to talk next time. And sometimes like today, we have the metrics, we have the logging. They are very
Yeah.
similar, very highly related.
Okay.
So maybe next time we can talk about that.
Yeah,
So
I think the logging part is, it is. I'm not sure if Abhishek or you worked on the distributed logging, but I think that itself is a very also good system design part.
yeah, and today's thing is typically the streaming and the batch system, and the next one similar. So,
Okay.
hi guys. I think we can stop here, and next time if you don't have any other topic you want to talk, let's talk about the logging. It's okay?
So you mean logging from the telemetry side, or creating a distributed logging kind of thing?
The text. So
Oh, okay.
that kind of logging.
Okay. Yeah, sounds good.
Okay.
Okay.
Thank
Thanks,
you.
guys. Yeah.
Thank you guys. See you
Bye-bye.
next time, same
Yeah,
time.
Thank you.
Thanks. Bye.